Recording in progress.
Okay, testing, 1, 2, 3. Should be okay, huh? Okay. Okay, so just now got cut off halfway, so I just start from the top. Okay, so for this one, just now I was saying that there's a heat transfer between these two objects, right? So the hot water transfer heat to the cold water because heat always go from hotter to cooler region. Okay, so the 7 degrees Celsius hot water will decrease in temperature and the 5 degrees Celsius water will increase in temperature. And eventually they'll reach somewhere around at the middle, in between, and they will have the same temperature. Let's just say that they reach 30 degrees Celsius. If these two objects, they reach the same temperature and they maintain that temperature, we say that they have reached thermal equilibrium. Okay, so when two objects, they are in contact with one another and there's a heat transfer from one to the another one until they reach the same temperature and maintain that, we say that that two objects have reached thermal equilibrium. Now remember, whenever a system is in thermal equilibrium, there will be no net heat transfer. No net heat transfer. When they have reached equilibrium, then there's no more net heat transfer from one to another. Okay, notice that I say net heat. Why I say net heat? 为什么我不要直接讲 no heat transfer 呢？因为其实真正当你是一样的温度的时候是30度的时候是，它不一定是好像 maintain 30度 perfectly 的，它有时候它会上一点，有时候它会下一点。OK， 所以它 constantly 它都会有 heat transfer 的。OK， 可是 heat transfer from object, let's say you got two objects, okay, A, B. Heat transfer from this object to this object and this object to this object, they are the same. They cancel out each other. So leaving no net heat transfer. Right? That's why I say no net heat transfer. Okay. So this is in the thermal equilibrium state. Remember, now you see, when I first place the metal cup inside the cold water, at that point in time, the temperature difference is the greatest, right? Because the initial temperature is, one is 70, one is 5. The temperature is the greatest when I first place it in. When you have the highest temperature difference, that is going to result in a faster heat transfer. Please take note of this. The higher the temperature difference, the faster the heat transfer will take place. So if I draw the graph showing the temperature change, let's say I have x-axis is time in minute, and y-axis would be my temperature in degrees Celsius. Okay, 70 over here, 5 over here. They reach 30 in the end, right? So this is the equilibrium temperature. If I draw the graph, that you will see the graph, it curves like this. And this one also curves like this. And eventually they go flat at the equilibrium line. Okay, so why this is curving down? It's not straight. This curve, it shows that the drop in temperature is the greater, right? So the heat transfer is faster over here. Okay, it's faster over here, and then slowly it taper off. Okay, it slows down here, and then eventually there's no net heat transfer. So the heat transfer always happens the fastest when the temperature difference is the greatest. So when you plot the graph, it is a curved line like this. Okay, so as long as there's a temperature difference, there's heat transfer. When the temperature becomes the same, then there's no more heat transfer. And this is the equilibrium state. Okay, now in the equilibrium state, there's a fundamental rule. There's a fundamental rule that says if you have three objects, let's say you have object A, object B, and object C. 如果我讲 object A 跟 C 是 thermal equilibrium 了，给我 short 它 TE thermal equilibrium， 然后 object B 跟 object C 也是达到 thermal equilibrium 了，将这个 rule 讲 A 跟 B 它们也会是 thermal equilibrium。 OK, I repeat 如果 object A 跟 C 达到 thermal equilibrium， 然后 object B 跟 C 也是达到 thermal equilibrium， 这样 A 跟 B 自动它会是 equilibrium。 What law is this? This is we call the zeroth law of thermodynamics. Why is it called zeroth law? Because actually in thermodynamics, right? Thermodynamics means the study of heat. Okay, the study of heat. So in thermodynamics, there are first law, there are second law, there are third law. We're not going to go through all this, okay? But just to let you know that there are all these three laws, but this law is found after the third law. Okay, this law is found after the third law, and then all the people they say that this law is so fundamental that it must become the first law. So, but the first law is already taken. The first law is already formulated. So they call it the zeroth law. They put it the zeroth. Okay, that's why you have they call the zeroth law of thermodynamics. It is something that is very fundamental, very basic. Okay, very basic. So they put it the zeroth. So this law, you can see it can be as simple as like I take one beaker, beaker A. I take another beaker filled with water, beaker B. So here I have two objects, right? Think of this as my object A, this is my object B. Object C is my thermometer. Okay, object C is my thermometer. Now I put the thermometer in object A. 我等它 heat transfer 到它 equilibrium. Okay, 每次你量的时候，你一定要 make sure 它 thermal equilibrium 了，你才可以 read 那个 temperature. Okay, so until become thermal equilibrium, I read the temperature. Okay, let's say it's 30. And then I take out, I put it in object B. Again, I wait for a few minutes, a few seconds, and then I read the temperature, 30. So object C is thermal equilibrium with A, right? And object C is also thermal equilibrium with B. And it reaches the same temperature. Then I would say A and B, they are also in thermal equilibrium. So they should have the same temperature. Okay, so this is the zeroth law of thermodynamics. It's related to the thermal equilibrium. Okay, now next part, we will look at how do we calibrate a thermometer. Okay, let me erase this. So far we discussed what? We discussed the difference between heat temperature. We discussed the transfer of heat, how it takes place. And also we just discussed the thermal equilibrium. Okay, and the next one, we go to the next one. Calibration of a thermometer. Okay, let me share my. Okay, suppose that I take a beaker filled with water, and then I want to measure the temperature. I put the thermometer in. How many types of thermometer, by the way? We got generally, we got 2 types. And we are talking about liquid in glass. Okay, liquid in glass thermometer, meaning that thermometer using liquid. Okay, there are other types of thermometer out there, but the most common one is the one that we use in the lab. They are all liquid in glass. Okay, the one that liquid in glass actually got 2 types. One is the mercury one. Another one is the alcohol. And in your science lab in school, usually you use what? You use the mercury, right? Mercury, but it's very dangerous because mercury is poisonous. Okay, it's poisonous. So they have another type also, the alcohol one, but they are both liquid in glass. Okay, because they use the liquid. Now, to measure the temperature of a substance, first we dip the thermometer inside and then we wait. Why do we wait? Because we want it to achieve what? Thermal equilibrium. Okay, we want the temperature of the thermometer to be the same as the water. So temperature is just what? Average kinetic energy, right? So when you put it in, then the vibration of the particle will transfer the heat energy to the mercury inside the thermometer. What happened to the mercury inside? When the heat is transferred to the mercury inside the thermometer, then the mercury temperature will increase, and when its temperature increase, then it will expand. Okay, when temperature increase, what happened to particle? They vibrate vigorous, right? More vigorous, faster. And then when they vibrate fast, they gain more kinetic energy. They have more kinetic energy. They can move further away from each other, so they expand. Okay, so 当我讲 particle expands， 它不代表那个 atom 啊，它的 size 变大，没有这样的东西。OK， 它 expand 的意思就是，let's say 你有4个 atom， 它 expand 就是它的 space 越来越远。OK，the space between the molecules getting further and further, and this causes the particle to acquire a bigger volume. That is the meaning of expand. Okay, doesn't mean that the particle itself increase in size. No such thing. Okay, because the particle cannot increase in size. It is the spacing that's they're getting further. Okay, temperature increase, they expand, they acquire bigger volume, so the volume will increase. Okay, now if you see the thermometer, let's zoom in a bit. We do a manual zoom. Okay, if you see the thermometer, right, inside there's a column, very small column, where the mercury is filled here, right? This is the mercury, red one. This is like the thick wall. Okay, this is like glass, this is glass. Only the middle column is filled with mercury. The cross section is very small and then it's fixed, right? So when the mercury expands, where will it go? There's only one way for it to go, which is to rise. Okay, it cannot go to the side. So it will rise, it will increase in the height or increase in the length. Okay, I'll just call it height. Okay, expand, increase in height. Now, all matters will expand, regardless of solid, liquid, gas. All 3 states of matter, they will expand. Okay, so this one, the thermometer, the principle of the principle of the thermometer is based on expansion actually. Okay, thermal expansion. Now, the mercury expand, increase in height until they reach thermal equilibrium, and then you only take the reading, right? Then you take whatever the temperature of the substance. So here we can say that the increase in temperature, okay, or we can say that the increase in height is proportional to the increase in temperature. The increase in height is proportional to the increase in temperature. The more increase in temperature, the higher it goes. And one very, very important thing also, if you see why we use mercury in the thermometer, actually, there's a reason. Because mercury, they expand very in a linear manner. You see it, linear. What does it mean, linear? Let's say there's an increase in 10 degrees. So the liquid inside the thermometer, it rises 1 cm. And that's 10-degree increase. And when there's 20-degree increase, how much it will rise? If 10 is 1, then 20 should be 2 cm, right? Yes, it should be 2 cm, right? So this is 2 cm. Assuming that every 10-degree increase, it goes up by 1 cm. So if we increase 30 degree, okay, there's a change in 30 degree, and then the mercury liquid rises by 3 cm. Here you can see for every 10 degree increase, it rises 1 cm. Okay, 10 degree 1 cm, 10 degree 1 more cm, and then 1 more cm 3. So every 10-degree increase, it rises 1 cm. So this, we call it linear. The linear or the linearity of the thermometer. Please take note of this. Okay, so how it looks like if the thermometer was not linear. If the thermometer was not linear, then maybe 10-degree increase, at first it rises 1 cm. And then you have the next 10-degree Celsius increase, and then maybe it rises 1.2 cm. Then this would not be linear anymore, right? This is not a linear thermometer. Okay, so in manufacturing of thermometer, it is important that you use a liquid that can expand linearly, like the mercury. Okay, because we don't want, like, for every change in 1 degree Celsius, suddenly you increase 2 cm, and then suddenly you increase 3 cm, suddenly you increase 1 cm. This is not linear, right? So we want this. Okay, so that is one of the reasons why we use a mercury. And also mercury, they do not maintain their linearity at very, very high temperature or at very, very low temperature. They only maintain the linearity in a certain range. Okay, but since we are using it to measure temperature, like usually it's like between 0 and 100, right? In the lab, okay, 0 and 100. So that range works fine. Okay, that range works fine. The mercury works fine in that range in terms of its linearity. Okay, now, so it's because of the linearity of the mercury, so it makes that the thermometer, it makes the calibration easier. 什么意思是 calibration 呢？ calibration 意思说我放 scale 进去 ，OK， 就是好像我拿一个 thermometer， 然后我放那种 scale 进去啊，哪里是100度，哪里是0度，哪里是1。It's like you're putting scale on a ruler. Okay, you're putting the divisions. Yes, you're doing the divisions and you're doing the marking on the ruler on any instrument. That is called calibration. Okay, so the placement of divisions and the marks on the measuring tool is called a calibration. So in calibrating thermometer, two things you need: two objects with known temperatures you need. The most important thing, or the most important mark of a thermometer is the 0 mark and the 100 mark. The 0 and the 100 mark, meaning that you need to figure out how do you get the 0 first and the 100. So to get the 0 mark, we put it in ice water, a mixture of ice and water, and it must be a pure water or a distilled, right? Pure water, meaning that there's no impurities, there's no stuff inside. So it must be pure water, because pure water, they freeze at 0. So when you take a ice pure water, then you know it is 0 degree. Okay, for 100 degrees Celsius, we use steam or boiling water. So we take a boiling water, also it must be pure water, and then we put the thermometer in. First, we put the thermometer here, we obtain the reading. Okay, and then it stops, maybe it stops somewhere here, and then we take, okay, this is the 0 mark. And then we take out, we put it in the boiling water. Okay, it rises somewhere here. Okay, I would say this is the 100 mark. And then now my thermometer got 2 marking. Okay, this is the bulb. The bulb is the one that is in contact with the substance that you want to measure. Okay, the bulb here, we would have 2 marking. One is 0 here, and then one is 100 here. Right? Now, how do we form the scale in between the 0 and 100? The scale between the 0 and 100, we can just divide it by 100 divisions. So we would measure the length here. We measure the length here, we divide by 100. 我们把它除100，除100，然后我就可以放100个格子，100个小 unit，OK，100 divisions。然后每一个 division 就是 represent 1个 degree。为什么我们可以直接这样子除100呢？因为我知道 mercury 是 linear 的。I know that mercury expands linearly, so I can just divide it. I can divide this by 100 with equal spacing. This spacing here, same with this spacing, same with this spacing. Okay, 100 equally spaced divisions to represent 1 degree mark. Okay, right down here. Okay, 100 equally spaced division. Okay, now example. Let's say 这个是我的 calibrated thermometer. 0 mark and 100 mark. let's say that this thermometer is only calibrated with the 0 and 100 marks. Okay, there's no other scale in it. I measure the length of the 0 mark. Now, every time I measure the length, usually the question, they will give you the length from the bulb. So you have to take note, you have to be careful of the length, which length they give you. Okay, let's say they give you this 5 cm. So the 0 degree is 5 cm from the bulb. And then the 100 degree is, let's say, is 30 cm from the bulb. And then they ask you, find what is the temperature when the mercury is at, say, 20 cm from the bulb. Then how do we find the temperature? Okay, they say that the mercury column rises to 20 cm. Okay, what is the temperature? Okay, then we use a very simple method. We use the cross multiplication. You see, if you look at your book, right, they give you all sort of formula, very complicated formula. No need to use that one. Okay, just understand what are you doing here. Okay, now first, you see the difference between 100 and 0. What is the length? 30 minus 5, right? This is the length. So 25 cm. I write down here, 100 degrees Celsius is 25 cm. And then this one, 20 cm, I count from the 0 mark. Okay, I count from the 0 mark, which means that from here to here, it is 15 cm. Right? 15 cm. So 15 cm, then what is the temperature? I write down here. X is the temperature I want to find. 15 cm. I'm just doing simple cross multiplication. Because it is linear, right? It is linear, so I can use this. I can use this method because the mercury expands linearly. And every single division represents 1 degree Celsius. Okay, so you just do the cross multiplication, and then, okay, 25x equals to 1500. X equals to 1500 divided by 25, you get, okay, 60 degrees Celsius. So the answer is 60 degrees Celsius. Okay, so here I'm just finding what does 1 cm represent. As long as you get what does 1 cm represent, then you can find the temperature. Okay, so always when you are given this question, always find, okay, what does 1 cm represent? And then you can find the temperature here. Okay, you want to take this, you can take this now. Well, 3 question gravitation, 1 question projectile, 1 question impulse and impulsive. 老师跟你们 discuss 了 answer 吗？我这个 test paper not yet. Okay. Oh yeah, haven't gotten back, right? The paper. Don't know the marks yet, right? Okay. Okay, let's go to the next page. Okay, mercury thermometer and alcohol. The differences. Okay, 我们先讲它的好处先。Okay, mercury thermometer 好处是什么？它可以 can measure high temperature, but not low. Okay, 很高的 temperature 它可以量到，低的它就不可以量到。为什么？因为它的 boiling point，它的 boiling point 是很高的，差不多356 degrees Celsius。它的 freezing point 呢 ？freezing point around -38 degrees Celsius. So you cannot measure temperature lower than that. Okay. So there's a limitation to mercury thermometer. Now alcohol, on the other hand, alcohol, it is the opposite. It can measure low temperature, but not high temperature. The boiling point of alcohol is very low, 78 degrees Celsius. So until 78, already boiled into gas already. You cannot measure. Okay. But the freezing point is very, very low. Freezing point is about -114.1 degrees Celsius. Okay, so these are the difference between mercury, alcohol. So usually, alcohol they use to measure lower temperature substances. So they normally use in the cold, like the colder region, like in the southern hemisphere and the northern hemisphere. Okay, they are using cold climate. And in the lab, usually you will see the mercury one. Now, second advantage is this expand linearly, right? Mercury expand linearly. And then mercury also, it has very high response rate, fast response, meaning that when you put it in the substance, then it responds very fast, it changes very fast. So there's no delay. Okay, for example, if you put it in, we don't want a thermometer that you put it in and then you wait for a few minutes, then only it rises. No, that one, the heat transfer happen very slow. We don't want. Okay, so we always want a fast response. This one. And also mercury, it is more durable. Can be used for longer term, more durable. Does not, because why? Because it does not evaporate easily. It has high boiling point, right? It does not evaporate easily. So it can last very long, more durable. And also, it is non-stick. Non-stick 意思就讲它不会粘着那个 thermometer 啊。Okay, it won't stick to the wall of the thermometer. Won't stick, yes. So we got 1, 2, 3, 4, 5. 5 advantages. All this you need to know also, because they might ask you, usually in the objective. Okay, alcohol can measure low temperature, and then also second advantage of alcohol is that they are less expensive. Less expensive. And number 3, they are less toxic. Less toxic. Okay, because mercury is toxic. Okay, that goes to the disadvantage. So disadvantage first, that it is toxic, meaning that it's poisonous. Mercury, right? It's not poisonous in the liquid state. Meaning that if you spill let's say you break the thermometer and then you spill the mercury on your hand. Okay, it won't really harm you. Okay, because mercury is not that toxic in the liquid state. It is the vapor that is the most dangerous. Meaning that if you inhale the mercury, then hanggang lah. Okay, so mercury is very, very poisonous in the vapor state. So when there's a spill of mercury, make sure you cover your nose. Okay, but if you accidentally like 好像你不小心你喝到 let's say 你喝到那个 mercury still it won't harm you, you know. 它也是不会有什么生命影响的，如果你不小心喝到 mercury. Okay, and 如果那个 mercury 动到你的手它可能会有一点点，可是也是不会怎样 harm 到你。可是那个 vapor 它会真的是会弄到there's a threat there. Okay, it's very dangerous. Okay, right. So it's very toxic, and then second, it's very expensive. Right. So yeah, usually the disadvantage of one will be the advantage of another one. Okay, so this is toxic and this would be less toxic. This is expensive, this is less expensive, and this is durable, this is less durable. Okay, you just flip the whole thing. Non-stick, then this is stick. This is stick wall. 1, 2. Okay. Okay, that's the difference between the mercury and alcohol thermometer.